Hello everyone, welcome back to Eclipse of Ideas. Today we're diving into a topic that transformed our understanding of the universe, Einstein's theory of relativity. Don't worry, we'll break it down into simple terms, so by the end of this video, you'll have a basic grasp of one of the most famous scientific ideas ever developed. Let's jump right in. So, what is the theory of relativity? In the simplest sense, relativity is about how things look and behave differently depending on where you are and how fast you're moving. It's like when you're on a train and it feels like you're standing still, but the world outside is zooming by. That's relativity in action. It's all about perspective. Now, Einstein took this idea and expanded it into something much deeper, splitting it into two main parts: special relativity and general relativity. Let's take a closer look at both. Special relativity was published in 1905, and it deals with how objects behave at very high speeds, close to the speed of light. Imagine you're in a spaceship flying near the speed of light. Weird things start to happen. First, time slows down for you compared to someone on Earth. This is called time dilation. It means that if you took a round trip through space at near light speed, you might age just a few years, while decades could pass on Earth. Mind-boggling, right? Then, there's length contraction. The faster you go, the more the space around you seems to shrink. So, objects in the direction you're moving look shorter. These effects seem impossible in our everyday life, but they've been proven true in experiments. Oh, and a key idea from special relativity that you've probably heard of is Einstein's famous equation, E=mc2. This tells us that mass and energy are basically two sides of the same coin. It's why atomic bombs are so powerful. Just a tiny amount of mass can be turned into a huge amount of energy. Now let's move on to general relativity, which Einstein published in 1915. This is where things get even more exciting. You see, before Einstein, people thought of gravity as a force between two objects. But Einstein realized something completely different. It's not a force at all. Instead, Einstein described gravity as the curvature of space and time, or spacetime. Picture spacetime like a giant trampoline. If you put a heavy ball, like a planet, on it, the surface bends. Now, if you roll a smaller ball, like a satellite, near the big one, it will follow the curve of the trampoline. That's how gravity works. Objects bend spacetime, and that curve guides how everything moves. So the reason Earth orbits the Sun isn't because of some invisible pull. It's because the Sun's huge mass bends spacetime, and Earth is simply following that curve. Okay, I know what you're thinking. How does any of this affect me? Well, relativity is not just some abstract theory. It's actually used in technology that we use every day. For instance, GPS systems rely on satellites orbiting Earth. These satellites are moving fast and are farther from Earth's gravity. Because of that, time runs differently for them compared to clocks on Earth. If we didn't account for time dilation from special relativity and gravitational time dilation from general relativity, your GPS would be off by miles. The implications of Einstein's theories are profound. General relativity predicts things like black holes, regions in space where gravity is so strong that not even light can escape. It also tells us that the universe is expanding, something we see through the redshift of distant galaxies. And here's something really cool. General relativity even allows for the possibility of time travel. While we don't know how to do it yet, the equations show that under the right conditions, it might be possible to bend space-time in a way that allows you to travel to the past or future. Einstein's theory of relativity changed our understanding of the universe forever. It's not just about big ideas like time, space, and gravity. It's about the way our reality is stitched together. I hope this video gave you a glimpse into how fascinating and important this theory is. Next time you're using your GPS or thinking about the stars, you can thank Einstein for explaining how it all works.